Hello guys, my name is Dylan. My YouTube channel is Zero to Bros, and today we are going to be doing Eigen Vectors 1. So topic 1 is going to be our review. So we learned about matrix notations last video, where we learned that A is 2, 1, 5, 3, and we use capital letters, and then B is 1, 2, and we use lowercase letters for column vectors. We learned about the transpose, which is 2, 5, 1, 3. We learned about the inverse vector, which is -1, or a -1, or the inverse A, which equals 3, -1, -5, 2. And then there's a thing called, it's a thing where if we star it, we use I. So for example, 3 plus I, 2 minus I, -I. And then we're gonna learn one, and that's called the trace. So the trace of A is equal to 2 plus 3 equals 5. The trace of B equals 3 plus I. And what we're doing is we're adding up these two. We add the corner. And so we also have the determinant of A, B equals the determinant of A times the determinant of B. And so if we say we want to find out the determinant of the inverse matrix, that equals 1, because the inverse matrix, or the identity matrix, is just this, and the determinant we learned is that if you multiply these two, and so this gives us 1. And so what we can say is that 1 equals the determinant of the inverse matrix, or the identity matrix. And so 1 equals the determinant of A, and then times A inverse A. And so 1 equals the determinant of A, determinant of A of inverse A. And so we can divide this by the determinant of A, and also the determinant of A. And so these cancel out, giving us 1 over the determinant of A equals the determinant of inverse A. So the determinant of inverse A equals 1 over the determinant of A. So moving on to topic 2. Topic 2 is going to be linear systems representation. So we could have our linear system right here. And we have 2x1 plus 1x2 equals 1. Then if we have 5x1 plus 3x2 equals 2. And so what we can say is that we can start our matrix equation. So 2, 1, 5, 3 x1, x2 equals 1, 2. And so this is A, this is X, there's an equal, and this is B. So what we have is AX equals B. And so we can multiply it by the inverse matrix, or inverse X, or inverse A. So we have inverse A equals inverse AB. And so this equals identity matrix of X, which equals inverse AB. And so that means that X equals 2, 1, 5, 3 inverse matrix 1 over 2. And so AX minus 2X is a special eigenvector problem. Moving on to topic 3, which is example of eigenvectors. So we can have something that looks like this. 2, 5, 5, 2. And then we have 1, 1. And so what we can do is we can see if this is an eigenvector. And so an eigenvector is when you multiply, multiply a vector together, and that if it's an eigenvector, you will get the same vector even if it's multiplied by something. So in this case, let's see. 1 times 2 is 2. 1 times 5 is 5. 2 plus 5 equals 7. So the top number is 7. Same goes for the bottom, so it's 7. But yet this is an eigenvector because this equals 7 times 1, 1. And so this even works through 3 by 3s. So we could say 2, 3, 2, 3, 2, 2, 3, 1, 3 times 1, 1, 1. This gives us, let's see, 2 plus 2 plus 2 is 7. 3 plus 2 plus 2 equals 7. 3 plus 1 plus 3 equals 7. And so we still get 7 times 1, 1, 1. You can do this for 4 by 4s, 5 by 5, 6 by 6, and so on and so on. Thank you guys for watching. I hope you enjoyed, and I'll see you next time. Bye.